Hello students, this is the most important part of this chapter, okay, and especially for understanding the sign convention. Okay, I have drawn a very simple diagram. So basically this is a concave mirror, this is the pole P of the mirror, okay, so pole P of the mirror, and it is the origin, consider it as origin, okay. So this is the principal axis and it is the x-axis, the horizontal axis, okay. So the distances that are on the left hand side are negative, right hand side are positive, above are positive and below are negative, above are positive and below are negative, okay. Now now consider this, forget about C, F and everything. This is a just consider this object AB. The height of the object is h. This is the real inverted image. The height is h dash. Okay, it's an inverted image. And consider this as the virtual and erect image formed behind the mirror, A dash, B dash. Okay, so its height is h dash. Height of the image is what? H dash. Height of the image is what? H dash. Height of the object is what? H. Okay. So this is the diagram. Now I will explain you. So equation 10.3 is what? M is equal to h dash upon h is equal to minus v upon u. Okay, and these notes I have created for the explanation that is present below equation 10.3 in the textbook. Okay, now so this is about the signs. Okay, so object distance u is always negative. Okay, the object is present here. So from here to here is the object distance. Consider it as 10 centimeter. So we will take u is equal to minus 10 centimeter because it is always negative. Why it is always negative? Because the object is always placed on the left hand side of the mirror. Okay, that we have seen in one of the earlier videos. So since object is always placed on the left hand side, the object distance u will always be negative. Okay, now for real inverted image, okay, all these points are very important. Okay, height h dash is always negative. Okay, so this is a real inverted image. Okay, why height is negative? Because on the axis, if you draw this x axis and y axis, so below the origin it will be negative. So how you write it here? Minus 1, minus 2, minus 3, and how you write 1 plus 2 plus 3, right? So if you measure this distance, so from here to here, okay, here to here means from here to here, see, so this distance will be negative. Since this is a real inverted image, we will measure it from here to here, that means from here to here, and it will, these are negative distances. So for real inverted image, height h dash, so this is height h dash from here to here, is always negative. Magnification is always negative. Means what? If you are told that an image is real and inverted and you are given that magnification is 2, that means you have to take m is equal to minus 2. Why you have to take m is equal to minus 2? Because magnification is always negative for real inverted image. Okay. Now you can check by putting it in this equation. M is equal to what? H dash upon h. This h dash is what? Negative. H is what? Positive. So if you have negative upon positive, the answer that you will get is negative. Correct? So the magnification will always be negative if for real inverted image. Okay. Now, but what happens for virtual and erect image? Consider this as the virtual and erect image. Okay. So this distance is present above these axes. Okay. So all the distances above are what? They are positive. Okay. So this could be 2 centimeter, for example. So for virtual image, height of image h dash is always positive for virtual and erect image. So this height is positive. Why? Because these distances are positive. Why this is negative? Because the distance below are negative, the distances above are positive. So h dash is positive for virtual and erect image. Okay. Now, so if what is the formula for magnification? It is h dash upon h. So if h dash is positive, virtual erect image, it is h dash is positive. So here it will be positive. Here also it will be, h is always positive because the object is always present above this x-axis. Okay, above this axis, horizontal axis. So if h dash is positive for virtual image, h is also positive. So positive upon positive will be positive. Hence for virtual and erect image, magnification m is always positive. Okay, so for real inverted image, h dash and magnification is negative. Virtual and erect image, h dash and M is always positive. Okay, very important point, these 2 points. Height of the object H is always positive. Okay, so H is always positive. The object will not be present like this. Okay, all the objects that we are going to consider in such ray diagrams or examples, they are always standing up like this. Okay, so this distance above the horizontal axis, these distances are positive. So H is always positive. Okay, now focal length F and radius of curvature R are positive for convex mirror. Okay, why they are positive for convex mirror? Because they are present on right hand side. Okay, if you see the you can check in your textbook or the PDF that I have earlier sent. The focus and center of curvature are on the right hand side for convex mirror. So the focal length and radius of curvature for a convex mirror is always positive. Okay, so focal length F and radius of curvature R are positive for convex mirror and negative for concave mirror. Like this is an example of concave mirror. Okay, consider this as concave mirror. So where is the focus present here? Where is the center of curvature? Somewhere here. Okay, so these are on the left hand side of a concave mirror. Okay, so since they are present, the focal since focus and center of curvature are present on the left hand side, the focal length and radius of curvature will be negative because they are present on left hand side of this origin. Okay, hence the focal length F and radius of curvature R are negative for concave mirror. Okay, so here on this page of the PDF we can see like this is a concave mirror. So F, so this distance is focal length. From here to here the distance is radius of curvature. Since it is present on left hand side, this focal length and radius of curvature are negative for a concave mirror. Okay, and they are positive for convex mirror. Okay, so all these points are very important. Okay, for solving the numericals.